So can you take the challenge to solve this question? This is IIT advanced level question. The question is e to the power x divided by x minus pi plus pi to the power pi plus e to the power e divided by x minus pi minus e. Third term is plus pi to the power e divided by x minus e is equal to 0 as four options are given. One real root in e pi and other in pi minus e. B is one real root in e pi and other in pi comma pi plus a. Two real roots in pi minus e comma pi plus a. And D is no real roots. So give a thought on this and then we'll solve it together. You can notice here when we simplify this left hand side into numerator and denominator, so it is not a polynomial of 2 degree, means it's not a quadratic equation. Like these two will be multiplied here, these two will be multiplied here, then these two will be multiplied here. So that denominator 2 at a time is a quadratic polynomial, but because of presence of exponential in x, the entire polynomial coming in the numerator will not be, entire function I should rather say, the function which is coming on numerator is not a polynomial. So let us simplify this first. इसका अप्रोच क्या किया जाएगा? अप्रोच यही है कि पहले मैं इसको सिंप्लीफाई करता हूँ. लेट अस सिंप्लीफाई इट. So can we write it e to the power x x minus pi minus e into x minus e, because these two will multiply here. With this term, this and this will be multiplied. With third term, this and this. So this is numerator, in denominator it is so this is the equation after simplifying, right? The top one is numerator, denominator. From denominator you can see it, this entire expression is not defined at x is equal to pi, x is equal to e, and x is equal to pi plus e. Because when you put the value x is equal to pi, denominator will become 0 and the entire thing will, the value of entire expression will be tending to infinite. Same way for e and pi plus e. So it means we know that x cannot be pi, x cannot be e, x cannot be pi plus p. So then how to get the real root of this equation? Now this is the challenge. So can we do one thing? Because this equation, this entire equation will be 0 when your numerator is 0, right? When the numerator is 0. So can we give a name to the numerator as function of x? So it is so we can write the numerator as fx, and we try to get the root of this function. But can we solve it? Because it is not a quadratic equation. So it is not simple to solve it. So what approach we should go for? Can we go for graphical way to solve it? Because you only have to find the real root in domain of x. You don't have to find exactly the root. So if we try to plot the graph of this, and we'll try to see like what all values, when we change the value of x, how many times it crosses the x-axis. So as many times it will cross the x-axis, that will be the number of roots of this function in the valid domain of x. You must have noticed, because here it is e and pi is with exclusive notation, means e and pi is not included in that. The value between e and pi is included, except e and pi. The same way for this, same way here, same way here, same way here and here. So these options are giving us a clue that this function we can try out at e, x is equal to e, x is equal to pi, and x is equal to pi plus e, the numerator function. And try to get like, okay, the value is at e is positive, negative, or at pi is positive or negative, at pi plus e is positive or negative, at pi minus e it is positive or negative. So that way you will come to know if it is, and then we will, so we can think in this way. Let me simplify it for you. You will try to plot the graph, a rough graph, by knowing the value. at pi minus e at e at pi plus e. So let us try now with fe. E is this, E is here on x-axis. This is your x-axis, this is your y-axis, which is function of x. So at x is equal to e, this will be 0, this will be 0. Its first and second term will be 0, third term will be this much. Pi to the power e, this is minus pi, so we can convert it into pi plus 1, and because of minus sign we can change the sign of e minus pi to pi minus e. Now pi is 3.14, e is approximately 2.74, so you can check on that. So this term is positive, this term is positive. So we can conveniently say that Fe is positive. Now we will check at pi. F pi. This term will be 0. So second term is 0. Third term is 0. So left with first term. E to the power pi. Pi minus e. E to the power pi. Minus sign is left over here, so we will change that. And this has become e pi plus 1, and then e minus pi. This one is positive, this one is negative, because e is smaller than pi. So f pi will be lesser than 0. F pi is lesser than 0. So now we will try out for pi plus e. Is equal to, when you put pi plus e, this term will be 0. So first term is 0. Then third term will be 0. So left with the second term only. So this one also is positive. You can see this is positive, E is positive, pi is positive. So this is so we have f at pi plus E, the numerator is greater than 0 and we are trying to plot this fx, right? So it is positive, maybe somewhere here. At pi it is less than 0, at pi it is less than 0, maybe here. At pi plus E greater than 0, at pi less than 0, at f E is positive. So here it is positive. So let us say these were the points. To reach from E to pi, this function, when we plot, there should be the line which must cross x-axis. So this will be one route. Now from pi to pi plus E, it has to cross again x-axis. So this is second route. Now we have to try out pi minus E. So let us try this pi minus E. Put the value. This is first term. Second term is calculate for this. No, this is okay. Pi to pi is cancelled. Okay. Here pi to pi is cancelled. Here pi to pi is cancelled. Here pi to pi is cancelled. So what we got for the first term? Minus E into pi minus 2E. Second term minus E pi minus 2E. Third term minus E minus 2e. Now you can check from here. Pi minus 2e is negative, right? Because e is approximately 2.7 something. So 2.7 into 2 is 5.4, where pi is only 3.14. So this is negative, this is negative. So first term is positive. Now we will try out, we will see the second term. This is positive, this is negative, this also is negative. So negative, negative, positive. So second term also is positive. Third term, this one is positive, these two negative, negative, positive. So third term also positive. So f pi minus e is positive. So means f pi minus e still will be on this side. After pi minus e is e. So the graph may be like this. It is going, and then because between pi minus e and e, the value of fx is not changing. It is the sign of fx is not changing. It is positive. Positive means above the x-axis. So it will not cut the x-axis. So we can confirm now that roots are at these two locations between e pi and pi plus e. So now you see the option and can confirm one real root in e and pi, that is fine, and other is pi minus e and e not, because pi minus e and e, the graph is not crossing the x-axis. So this one is not. One real root in e pi, yes, this one, and other in pi plus e, yes, this one. So B is okay. Two real roots in pi minus e and pi plus e. So between pi minus e and pi plus e, there are only two roots. So this also is correct. This is wrong. So our answer will be B and C. So you have to take the advantage of options, what is given in the options, and try to get it from there, because it is not asking the value of real root. It is asking whether it is having the real root or not in domain of x. And you can notice that e and pi is excluded. Why? Because at e and pi this whole expression is undefined, is not defined. E, pi and pi plus c, denominator will become 0. So this complete expression will tend to infinity. So that is why in every domain these values are excluded. So hopefully you understood the crux. Anyone, any doubt? Thank you.